Welcome back to my YouTube channel. In the course of this video lesson, I'll be teaching on a very important aspect in chemistry, and that aspect is simply called stoichiometry. And in the course of this video lesson, I'll be solving different practice questions that cut across this topic, stoichiometry, from scratch up till mastery, to ensure that whenever you see any practice question under this aspect of chemistry, you can solve it without stress. So make sure you watch this video till the end to learn every single concept under this topic. This video lesson will be arranged into parts, so watch closely. Actually, I classified solving questions under stoichiometry into 3 parts. All right, so you can see now that we are just starting, and all of the questions I'll be solving first definitely will be on part 1. So just watch and learn everything you are supposed to learn under this topic. So let's get into the first practice question, and it says calculate the number of moles, all right, listen carefully, present in 10G. This G here simply means grams. So present in 10 grams of this compound. That name I saw is actually a compound, and it is soda ash. So I read again. It says calculate the number of moles present in 10 grams of soda ash. So what do we do to solve this question? This question is extremely very easy. Now, this must be noted. In solving questions under stoichiometry, there are 5 basic formulas that must be noted. I'm not going to write the formulas once. I'll be solving different questions to bring out those 5 formulas. So just watch closely. So for sure, this question on the board requires a formula, and I'll be giving you the formula. Not just giving you the formula, I will tell you why I am to use that formula. So in solving questions generally in chemistry that has to do with formula, you have to try to understand the question to know exactly the formula to use to solve that question. Not just in this topic, other topics in chemistry. So just watch closely to the way I'll be solving this question and more other practice questions in the course of this lesson. So moving further, in this question, I saw a key word or a key phrase, and it says calculate the number of moles. Wow, listen carefully. In this question, they are asking us to calculate the number of moles present in 10 grams of this compound. Now just relax. I'm going to tell you the chemical formula of this compound. But first of all, we have to understand what we are calculating for, which is number of moles. Now listen carefully. This must be noted about number of moles. It must be noted here that number of moles has a symbol to which it is noted. Now the symbol for number of moles is simply N. Are you there? And this number of moles has 5 basic formulas. As earlier said, in the course of this lesson, I'm going to give you all of these formulas. So just watch closely. Now, I also told you that writing the correct formula for number of moles is based on your question. Now, listen carefully. The question says, calculate number of moles. Yes, we know that. And I just told you that number of moles is symbolized as N. Now, they now say something. Present in 10 grams. Wow. You know, anything that is expressed in grams definitely is mass in science. Hope you are aware about that. Anything that is expressed in grams definitely is mass. And there is a formula that actually relates number of moles and mass together, and as well another parameter which you see on the board, and that formula for number of moles is simply N is equal to mass, listen, mass divided by molar mass. I believe you are following me. So that's the formula for number of moles whenever we are giving mass in that question and they tell us to calculate number of moles. Definitely for the molar mass, we are to use the compound given to us or the element given to us. So here now the next said that present in 10 grams of soda ash. Now this must be noted about soda ash. It must be noted here that soda ash is a compound and it has its chemical formula to be this. Listen, this is the chemical formula for soda ash. It is simply Na2CO3. So you can see that soda ash is actually a compound. And I just told you that we can get number of moles for compounds or elements. Don't worry, we'll solve more practice questions to be able to understand all this. They are all very easy. So you can see we've identified the compound soda ash to be Na2CO3. In the GEM exam, sometimes they will just write the compound's chemical formula and they will write the name of it. You understand? So sometimes they might write the name, so that's why it's very important for you to know several names of different compounds. They are very key. So as you've known this now that soda ash is Na2CO3, you should not forget it. So moving further, let's calculate the number of moles. So number of moles will be, what's the mass? Mass is actually 10 grams. 10g. Are you there? Divided by molar mass. All right. You can see that the question did not give us molar mass. Then we have to calculate molar mass together. So listen and I will teach you how to calculate molar mass of compounds. They are all very easy. Just watch closely. This is the compound Na2CO3. So basically, let me just put this in a box. So now how do we calculate molar mass of compounds? To calculate molar mass, we need what we call atomic mass. Though in most exams in chemistry, you will be given the atomic masses of these elements. This is what I mean, just relax. So here is the compound. It is Na2CO3. So let's calculate the molar mass together. So molar mass will not be, now first of all, how many elements are involved in forming this compound? The first of the elements I'm seeing here is sodium, Na. Leave the numbers alone. What's the next element? Carbon, C. And what's the other element I can see? Oxygen, O. All of these elements have their atomic masses. Though in most exams, you will be given the atomic masses, but it's key for you to know them. Now, for sodium, the atomic mass is 23. For carbon, the atomic mass is 12. For oxygen, the atomic mass is 16. Are you there? So moving further, let us calculate the molar mass together. Is going to be you adding the atomic masses of these elements. So for sodium, what's the atomic mass? 23. So under sodium, I write 23. All right. How many of sodium do we have? We have 2 of sodium. So those numbers that we have in front of them, we times them. So 23 times 2. I believe you are following me. Moving further, you can see I'm done with sodium. I'll go back to the next element. So go back to the next element, you plus, you add, you add. So for carbon plus, what's the atomic mass of carbon? It is 12. Are you there? There is no number attached to carbon, so I'll just write 12. If there was a number like 2, 3, 4, 5, I'm going to times it with that number. I believe you are following me. For oxygen, I'm going to oxygen, so still plus. Oxygen is 16, so 16 times 3. So what should be everything when we eat them in our calculator? So we are getting the molar mass of Na2CO3 to be 106 grams per moles. So this must be noted. You must know here that the unit for molar mass in chemistry is grams per /moles. Are you there? And we've calculated the molar mass to be 106 grams per mole. So under molar mass, I'm going to put what? 106 grams per what? Moles. So first of all, gram will cancel gram. Are you there? Making the number of moles present in 10 grams of soda ash to be, so 10 divided by 106, that is 0.09434. All right, so we're having 0.094, all right, 9434 moles. 34 what? Now you can see it's just moles remaining. So I'll just put it on, or can write moles in full. You get moles of which compound now? Soda ash. Are you there? We calculated the number of moles of our soda ash, which is what? Na2CO3. So you can see how questions under this aspect using the first formula for number of moles, how it works. It's very simple. It is not difficult because there are extra 4 formulas for you to note. And at the end of doing, because I told you I'm going to arrange this video into parts. Actually, we are still in part 1. We've not entered part 2, part 3. So we must master how to use these 5 formulas. We just understood now how to use this, formula 1 you get. So let us progress to solve more practice questions under this aspect. But before I progress, I'll give you one practice question so you solve and provide the answer in the comment section. And here now I'm going to change it to be 2.5 grams, whereby for the compound I will change it to a compound that is very popular, and it is limestone. And everybody should know here that limestone is CaCO3. You can see it's between calcium, carbon, and oxygen, whereby calcium atomic mass is 40, carbon is 12, oxygen is what? 16. So you calculate the number of moles for me in this particular question. So we'll go back to another practice question. At the end of solving that question, I'll give you one practice question like that, so as to make sure that you master it very well. Okay guys, let's get into the next practice example. This is question number 3, because the question I told you to solve is question number 2, like that, so that I can be able to number them correctly. So let's go over to solve this question. It is very easy. I am still on using that first formula to solve question. We've not entered the other formula. I told you we have 5, and we are still on formula 1, you get. So just listen. And what's that formula? It is number of moles is equal to mass divided by molar mass. So just watch closely. Solving questions generally on this topic is very simple. So let's get straight into this question. You can see that this question is asking us to calculate the mass. Wow. Present in 4 moles of calcium. Very easy. We are looking for mass, and they mention moles, and they mention a particular element. What formula relates all these things you've just seen? Mass, moles, and an element or a compound. It is the formula I gave to you initially. So solution, what's that formula? It is simply number of moles N is equal to what? Mass divided by what? Molar mass. I believe you know all these. They are very simple. So in this question, what are they asking us to calculate for? Calculate the mass. So what do we do first? We make mass subject of formula. To make mass subject, we cross multiply. We are making mass subject of formula. So when we cross multiply, mass with times 1. So we're having something like mass, mass times 1, mass as times 1, this will times this, is equal to, there's an equal to sign, so this will times this, N times molar mass. Hope you are following me. All these things are very, very easy. You get, we've done it already, because mass times 1 is nothing. There was nothing here. I just decided to put 1, you get, so as to show you what is happening. So this 1 is out already. So we just have mass is equal to number of moles times what? Molar mass. So first of all, you can see here that we were given an element. Now, listen very well. Calcium, what's the, before we get molar mass, now remember, I mean, here that before we can get molar mass, we need atomic masses of the elements, all right? So the question you asked me, what's the atomic mass of calcium? Only calcium, it is 40. But converting 40 into molar mass, what becomes it? It becomes 40 grams per mole. Hope you are aware now, because in the formula we have molar mass already. This is not a compound that we can now start adding all the atomic masses of the element. This is just a single element. And you already know that calcium atomic mass is 40. You'll be given in the question, so you don't have to stress yourself, but it's good also you know it. So then, bringing it in form of molar mass, you just add the units, grams per moles. Are you there? So doing that, calcium molar mass becomes 40 grams per mole. What becomes the mass? All right, mass of which element? Calcium is equal to, what's the number of moles? So I'm giving 4 moles. So here we'll just come here, right? 4 moles or 4.0 moles, same thing. All right, times, what's the molar mass of the element? 40 grams per mole. So 40 grams per moles. So what happens for us to get the mass? The moles cancel moles. Hope you are aware, because this is mole, this is mole. Just like this one, there is no E and S, but it's still moles. So basically, what's remaining? 4 times 40. All right. So 4 times 40, what becomes that? 160. So the mass, listen. So the mass of calcium becomes 160. What unit is remaining? Grams. And they're asking us what mass. And you already know that the unit of mass is what? Grams in chemistry, not kilograms. If we're talking about physics, that's when it's going to be kilograms. Hope you're aware. So here is your own practice question, making this question to be question 4 for you. So here I'm going to change here to 2.3 moles, and then the elements to change to sodium. You get. So you should know here that sodium atomic mass is not 40, but rather it is 23. So you should change 23 to 23 gap and more, and solve and write the answer in the comment section. So let's get into the next practice question, which is question number 5. Okay guys, let's get into the next practice question. This question is extremely very easy. We are still on the first formula, solving questions on the first formula for number of moles. So just listen carefully. Let's read this question together. The question says, calculate the number of moles. Wow. In this question, I'm not done reading the question. I'm going to finish reading before we start solving. But this question is asking us specifically to calculate for number of moles. Wow. And everybody knows that number of moles is n, will come to that. Just listen. So let's finish. Present in 1 kilograms. Wow. Present in 1 kilograms. I told you that grams, kilograms are basically units for mass. But in chemistry, we work more with grams and not kilograms. So I agree that, okay, 1 kilograms is mass. But in chemistry, our mass should be in grams, not kilograms. And I will explain to you how to change this mass from kilograms to grams. Just watch closely. So me seeing kilograms here, which is a unit for mass, is a confirmation that I'm going to use the formula for number of moles, which is the only formula I've given to us, to be number of moles is equal to mass divided by what? Molar mass. I'm going to give you the other formulas, so you just relax and pay close attention. Now let's finish reading the question. The question says, calculate the number of moles n present in 1 kilograms, which is mass, but our mass should not be in that unit. It must be converted to grams. I will teach you how that is done. All right, of copper 2 oxide. All right, this now, you can see what is happening in these questions. They are not making things easy for us, but don't worry, I'm going to make it easy for you. All right, you can see here that they are giving us the chemical names of the compound, because we don't really need the chemical names to solve this question. All what we need is the chemical formula. But don't worry, I'm going to teach you how to get chemical formulas from chemical names. Just pay close attention in solving questions under this aspect. Remember, at the end of solving this question, I'm going to give you all practice questions to solve to master this aspect properly. So first of all, we need the correct chemical formula to be able to calculate the molar mass of the compound, so we can impute it here and as well as the mass up here. And I told you here that we'll teach you how to convert kilograms to grams. Very simple. You just need to know a little conversion. And what's that conversion? You should know here that in mathematics or in science, 1 kilograms is equal to, is same as 1,000 grams. Are you there? So anywhere I'm seeing 1 kilograms, I'll remove it and put 1,000 grams. So here that we have a number of moles is equal to mass divided by molar mass. So the mass becomes now 1,000 what? Grams. Please pay close attention. So moving further, you can see we've sorted out the mass. Let's sort out the molar mass. Before we do that, we have to bring this thing down and get the correct chemical formula from this chemical name. And what's the chemical name? Is simply copper 2 oxide. They even made things easy for us. They told us that copper is 2. Copper 2. Oxide. Wow. So first of all, we have to bring out the elements involved to form this compound. And there are two elements. What are they? Copper and oxide. And oxide there tells us that it is oxygen. And we should know the chemical symbols of this element. Copper is Cu. Copper is not Co. Co is cobalt. All right. Oxide simply means oxygen is present here. And they made things easy for us. They told us that copper has a state, a valency. All these are simple, just relax. We have what we call valency, which is the combining power of an element. Basically, the valency of copper in this compound was 2. And copper is a metal, and all metals are positively charged. And this is how we write it. So the valency of the charge becomes 2 plus, all right? Because I told you that, copper is a metal and all metals are positively charged. Oxygen is a non-metals and all non-metals are negatively charged. And this is something you should know about oxygen. Oxygen has its own valency to be -2. Oxygen in some other cases have another valency. But in most cases is what? -2. So up here I'm going to write what? -2. Are you there? Remember, what did I call all of these numbers? I call them valency or oxidation states. Valency is simply the combining power of an element. All right, it's the element's power that helps it to combine to form a compound. So this is how compounds are formed. For we to form compounds, we exchange the charges they have. We are going to exchange the valencies they have. So this 2 for copper will give it to oxygen, all right? So it's going to be something like this. Are you there? Whereby this oxygen charge will pass it over to copper. Are you there? So this is how it works. So copper, right? Oxygen has passed its own charge. And what charge did oxygen pass? Is the 2 minus charge or the -2 charge. Actually, when we are exchanging it, we don't exchange the signs. It's just the numbers that are moving. All right, the signs now goes away. So bringing this number here is going to be 2, and bringing this 2 here is going to be O2 as well. So actually, the chemical formula of copper 2 oxide is CuO2. But in chemistry, we always make sure that our compounds are existing in the simplest form they can. Actually, since we've seen that, okay, we have Cu2 and O2, it means that these two can actually cancel each other. Are you there? But in some other cases whereby you've done it and you see that it's different numbers. In some other cases whereby you have different numbers that are not dividable, you cannot divide them with each other. Don't cancel. Don't worry, I'll give you examples. You just relax. They are all very easy. So this is what I mean. We've cancelled out. So we are having copper 2 oxides chemical formula to be CuO, you get, because we removed the 2. But in other cases whereby we're having 2 different numbers and you cannot divide them with each other, leave it like that. You understand? Don't worry, I'll give you a practice example. So I believe now we've agreed that the chemical formula of copper 2 oxide is CuO. You will not be told. That's why you have to learn it. They are all very easy. You get. To get for the metals or charge is majorly, they will give you the question. If here will be copper 3, they will tell, but we don't have it like copper 3. You understand? If it's going to be 3, they will tell you. If it's going to be 4, if it's going to be 5, you'll be told. But oxygen majorly, exists in various compounds. You should know here that oxygen charge is -2 always. For this other part, they will tell you. Hope you understand it. Because I'm going to give you all practice questions to solve and provide the answer in the comment section. So moving further, after getting the chemical formula, we have to get the molar mass. So here we come and say CuO. So then we have to know here that there are 2 elements, copper and oxygen. Copper atomic mass, something you should know, it is 64. All right, oxygen atomic mass is very popular. It is 16. So to calculate the molar mass, we simply come here and say 64 plus 16. There's nothing to type because just CuO. So 64 plus 16, that's 80. So we have the molar mass of this compound to be 80 grams per mole. So underneath molar mass, we're writing what? 80 grams per what? Moles. So gram cancel grams. So what becomes number of moles? It's going to be 1000 divided by what? 80. All right, 1000 divided by 80, that's 12. All right, that's 12.5 moles of what? CuO of copper 2 ox. So these are questions under this aspect that are tackled without stress. They are all very easy. So get ready for your own practice question, which is question number 6. That's your own. And I'm going to change that 1 kg remains there, but the compound, I will change it to something like iron. All right, iron 3 oxide. This question is simple. Please pay attention. Iron what? 3 oxide, whereby iron basically is Fe. That's the symbol. Oxide remain, oxygen. But in this case, they said iron 3 and oxygen is -2. So you exchange, you understand? Exchange and tell me what you get. They're all very easy. Iron atomic mass is 56. Oxygen doesn't change, it is what? 16. So you solve for everything and tell me the answer in the comment section. They are all very easy. So this question number 6. So let's get into the next practice example. You can see that we are still on one formula. It's best you understand and master it very well before you go to another formula you get. And we are still on part 1. So it's best you know these stuffs very well and perfectly. So let's get into the next practice example, which is question number 7. All right, okay guys, let's get into the next practice question, and it says 1 moles, all right, of a compound XHCO3. The compound is not complete. Okay, let me finish first. It means that you having X here, it means that there is an element that should be here. But let's progress. I read again. It says 1 moles of a compound. This is the compound, has a mass. All right. This is the compound, has a mass. All right. They told us that this compound, which is not complete, there's something that should be here, has a mass of what? 84 grams. So the question now says, calculate the atomic mass of X. Wow. So basically, all those atomic masses are what we use together to calculate molar mass of compound. And then this element is not known. Then there's no way we can just get the atomic mass like that. So it's very important for us to calculate for the atomic mass. And to do that is extremely very easy. Just watch and see how I'm going to solve this question. Based on what they give to me, that's what I will use. So just relax, and at the end of solving this question, I'll give you a practice question to solve and provide the answer in the comment section. And the question says, all right, let's go. It says 1 moles. Wow. So the number of moles in this question is 1 moles. So you can see here that they just wrote it in words. Some students might be like, oh, they did not give us number of moles. They gave you, they said 1 of it, 1 moles. So basically, number of moles N should be 1. They must not write it in numbers before you know that it's moles you get. So moving further, what do we do next? It said 1 mole of a compound, that compound which is not complete, has a mass. Wow. It has a mass of what? 84 grams. They now told us to calculate the atomic mass of X. So what should we do? First of all, I believe we are aware that there is a formula that relates number of moles and mass and as well as molar mass together. And what's that formula? It is N is equal to what? Mass, listen, divided by molar mass. So in this question, we were given N and mass. All right. So the only thing we're not giving, because if this compound was complete, then we'll be giving molar mass. So since the compound is not complete, there's no way we can actually get the molar mass you get. So normally the way we get molar mass now is by bringing the compound down and calculating all of them. So you can see that element X is here, and it's supposed to be a particular element. So what do we do? Very easy. Just pay attention. The first step to take to solve questions under this aspect is to first of all get the molar mass based on your formula. So first thing we have to do is to make molar mass subject of formula. So to do that, I'm going to divide by 1 and then cross multiply. I'm making this subject of formula. So first of all, to make molar mass subject, let's cross multiply. Watch closely. So me cross multiplying is going to be molar mass, listen. I want to cross multiply first. Molar mass times N, that's what it means. So molar mass, listen, times N. This equal to is still here. We are cross multiplying. So equal to mass times 1, you get, or we can just say equal to mass, you get, because 1 is nothing. Hope you understand. We can say times 1, but it's still nothing. I just wrote that so you can see how we are going to cross multiply. Remember, we want to make molar mass subject of formula. What does that mean? You want to make sure that molar mass is standing alone. Nothing else should be attached. So basically, to do that, we divide both sides of the formula or the equation by the coefficient of molar mass. What does that mean? It means that we are going to divide both sides of the equation based on what is standing close to molar mass. What is standing close to molar mass is n, so I'm dividing both sides by n, so that this n here will cancel this n, you understand, making molar mass to stand alone. So if molar mass stand alone, we are having mass divided by n. All right, what's the mass given to us by the question? 84 grams. So on mass, I'm going to write 84 g divided by 1 moles. All right, divided by what? 1 moles. So basically, 84 divided by 1 is still 84. So bringing your units together, we are having the molar mass of this compound, listen everybody, to be 84 G. All right, this divide means slash, you understand. G slash moles, because I need it to tell us that, okay, the number we've gotten is molar mass. You get. Hope you are aware about what is happening. So what we've done now, we've calculated the molar mass of the compound. So the next thing to do is to bring out the compound and let's write it here. The compound now is what now? XH, all right, CO3. Normally, we actually don't need to do this. So get molar mass is just to take the atomic mass. Like for hydrogen, it was given to us to be 1. You understand? Carbon 12, oxygen 16. But they did not give us for X. You understand now? They don't give us for X. So there is no way we can get the molar mass. But based on this other alternative, we've gotten the molar mass. So let's just say that, okay, this compound is equal to the molar mass. Because definitely when we add all of them together, we are supposed to get the molar mass, and we've gotten it already. So now we've gotten the molar mass to be what? We've gotten it already. So molar mass will now be equal to what now? 84 grams per mole. So the reason for doing this is to make sure that we can get X. It's very simple, just little mathematics. Just listen to the way I'm going to solve this question. So the next thing to do is to now start writing X is unknown. After solving from a particular element, you plus. So going over to hydrogen is going to be plus. What's the atomic mass of hydrogen? 1. Plus what's the atomic mass of carbon is 12. Plus what's the atomic mass of oxygen is 16. And we have 3 of it. So 16 times 3 is equal to the overall molar mass, which we've gotten using the parameters given to us. So basically, it's equal to 84. Let's remove the units for now so we can solve very fast. So basically, the next thing to do is to now add all of these things first. So 1 plus 12 plus 16 times 3, that's 61. So X plus everything here is 61. All right, 61 is equal to 84. I believe you now see what I'm doing to ensure that we make X subject of formula, to ensure that we can get for X. So basically, to get X, this plus 61 will come here. You understand? When it crosses equality sign, it changes to minus 61. Hope you are aware. It's very simple. So basically, what then happens next? X now is not standing alone because plus this one has come to this other side. So we've removed this. So X will now be 84 minus 61. So what becomes X? X will now be 84 minus 61. 84 minus 61. What's that? 23. Wow. So the atomic mass of X is 23. And there's an element that corresponds to this 23 being an atomic mass. And that element is actually sodium, Na. Hope you are following me. All these things are very simple. So here we are having XHCO3. I can decide to remove it and just put what? Sodium, NHCO3. Hope you are aware. So all this must be noted. You can see how this question was tackled without stress. So get ready for your own practice question, and I'm going to give you a practice question. It's still 1 mole of a compound, but this time around I will change the compound entirely. And let's say, for instance, I make the compound to be X again, but here is Cl, has a mass of, let's say, here is 58.5 grams. Yeah, 58.5 grams. Yes, I'm good to go. So you solve this. This is question number 8. So we'll get into the next practice question. And at the end of solving, try to still predict the elements. All right, they are all very easy. Let's get into the next practice question. Remember, we are still on the first formula, but I think the next question will be solving questions on the other formula. We have 5, we've solved on 1, so let's get into the next now. So if you find my video lesson helpful, make sure you click on the subscribe button to my channel and also share my lessons with your friends. All right, so let's get into the next practice question, which is question number 9. Okay guys, let's get into the next practice question, and the question says calculate the number of moles. Wow, we are still asked to still get number of moles, all right? And everybody knows here that number of moles is n, but now we have to be careful. The format of the question has changed. Present in, wow, 200 cm cube. Remember, it used to be present in something g, grams. So you can see that, oh, in this question there is no way we have to use that formula. So that's why you must know another formula that is used for solving questions under this aspect, which is present in 200 cm cube of 0.1 mole per dm cube HCl. First of all, before we solve this question, it's important for me to tell you some key things, all right? So any number in science that ends with cm cube actually tells us that that number is volume. And any number also that ends with moles per dm cube, listen, any number that ends with moles per means slash, all right, per dm cube. So this is pronounced as moles, all right, per, because slash means per, and dm cube. Anything that ends like this is literally curd concentration. Please, if you don't know it before, know it from today. I believe you are following me. All these things are very simple. And there is a formula that relates both parameters, both words, which is volume and concentration. For number of moles, there is a formula. And what is that formula? I'll write it on the board. The formula is simply number of moles is equal to concentration. Listen, concentration times volume. Now pay close attention. I'm going to write a unit for this volume. Let us say, for instance, in a practice question, the volume was given to be in dm cube. Listen, we are going to divide by 1 or divide by nothing, because this formula can be expressed in another way. This is what I mean. We've seen the formula already, so I want to write it in another way. For number of moles, it's still the same parameter, which is concentration, all right, concentration times volume, all right. But in this case now, the volume is not expressed in dm cube. The volume is expressed in centimeter cube. Whenever we have something like this, whenever your volume in the question was given to you in cm cube, make sure you divide by 1000. You can see in this question, the volume was given to us as 200 cm cube. Cm cube. Concentration does not change. It's still moles per dm cube. So then, based on my explanation, which formula am I going to use to solve this question? Is it the first or the second? The second. Because in this question, volume was given to us in cube. So then, number of moles will now be concentration. What is concentration? 0.2 moles per dm cube. So here becomes 0.2, all right, times volume. What is the volume in the question? 200, all right, 200 what? Be specific with your unit so you don't make mistake. Volume is 200 cm cube. So what should I do? Divide by 1000. If the volume was in dm cube, I will not divide by any 1000. Hope you are following me. All this must be noted. So let's hit the values in the calculator so we get the answer to the question. So 0.2 times 200 divided by 1000, that is 0. Wow, we have a number of moles to be 0, all right, 0.04. Remember, what's the unit for number of moles? It is moles you get. So this is the answer to the question. It is not difficult, it is very simple. And here is your own practice question. So you solve and provide the answer in the comment section. The volume has changed now to, let's say, 5 dm cube. I've changed to 5 dm cube, and then the concentration is now 0.1. No, 0.03. Yes, and this is question 10. So solve this question and provide the answer in the comment section. So over to another practice question, and this question I'll be solving next is based on another formula. This formula doesn't have many stress you get. It's just you understanding these two concepts I just gave to you and you are good to go. Let's get into another formula. Remember I said that we have 5 and we are still in part 1. We've solved the one, we have solved now on this, we are in another formula. So let's go straight into that formula so we can progress. Okay guys, let's get into the next practice question. And this question is on another formula for number of moles. You can see here that the question says calculate the number of moles. We are still looking for n. But let me just tell you something. Whenever in a question you see that they are asking you to calculate number of moles of an ideal gas, take notes, there is a formula for number of moles you should not forget. And that formula is simply number of moles, which is n, is equal to PV divided by ROT. Listen carefully. Whereby P here means pressure, V here means volume, T here means temperature in Kelvin. I must specify. T here is temperature in Kelvin scale, and rho is a constant called the molar gas constant. What's rho? Is a constant called the molar gas constant. And now this must be noted. Actually, we have two major constants for the molar gas constant, which is rho. In the course of this lesson, I'll be using, listen, in the course of this lesson, I'll be using just one out of the two, because if you understand one perfectly, you'll be able to solve any question under this aspect. I'll be using just one, and that one I'll be using is this constant, which is 0.08205. Are you there? This must be noted. Now, moving further, to use this constant, which is rho, called the molar gas constant. If you don't call it that, you can call it the ideal gas constant. There is a criteria. All right, the criteria is based on volume and as well based on pressure. What's the criteria? The criteria states that whenever we are using rho to be this constant, our volume in that question must be in dm cube. Are you there? The volume in that question must be in what unit? dm cube. Whenever we are still to use this constant, pressure in that question must be converted to ATM. ATM here simply means atmosphere. Are you there? So you just listen carefully to the way I'm going to analyze this question. We'll go back to the question and bring all the parameters out, so we analyze them one after the other. So basically, let's bring out the parameter. The formula says number of moles is pressure, volume, pressure P times V over R times T. All right. So from this question, what's the pressure? The question says calculate number of moles of an ideal gas, all right, present in 300 cm cube. All right. V here is what? 300 cm cube. And question right is, and from what I told you guys, whenever you have to use your arrow to be this, definitely you must put something for arrow. Whenever you are using arrow to be 0.08205, your volume must be in dm cube and not cm cube. And I will teach you how to convert volume from cm cube to dm cube. All right, exactly the pressure of 700 mmHg. Same applies to pressure. Our pressure that is in mmHg now must be converted to atm pressure, and I will teach you how that is done. All right, so at 27 degrees Celsius, all right, so T temperature is 27 degrees Celsius, and I told you that it must be in Kelvin scale, and rho now is what we've noted, and it is 0.08205. So basically, what do we do now to solve this question? Before we impute all of this parameter into the formula to get n, we have to make sure that they are in the correct unit. So first of all, let's convert volume from cm cube to dm cube. All right, so here will be a volume conversion. So listen carefully, volume what? Conversion. So basically, to convert from cm cube to dm cube, this must be noted. You have to know a conversion factor that relates both parameters. You must know here that 1 dm cube is equal to, listen, We are converting this to dm cube, all right? So 1 dm cube is equal to 1000 centimeter cube. That's 1000 cm cube. Are you there? So based on what we are looking for x dm cube. So you write it down. Please, this how it's done. Follow instructions. Is equal to what the question gave to us, which is what? 300 what cm cube. Are you following me? So what becomes the next thing to do is to now cross multiply to look for x dm cube. So what becomes x dm cube is going to be 1 times this, all right? All right, 1 times this divided by this. Hope you know how to make something subject, or let's do step by step. All right, so just listen. So basically, we are having x dm cube. All right, we are multiplying, so times 1000 centimeter cube, all right, is equal to this times this, all right? 1 times 300, 1 dm cube times 300 what cm cube, all right? 1 dm cube, all right, times 300 cm cube. So basically you are looking for this, so we divide both sides of the equation by the coefficient of this, which is 1000. What is close to dm cube, which is 1000? So we are dividing both sides. So basically, we are dividing by 1000 centimeter cube. All right. So basically, 1000 cm cube cancel 1000 cm cube. I will do same here as well. Hope you are following me. All these things are very simple. I can cancel now because if there's nothing 1000, I hope that I can cancel. So basically, class, what becomes x dm cube? So x dm cube will not be, x dm will not be everything here. 1 dm cube, all right, times 300 cm cube divided by that 1000 cm cube. You understand? So basically, cm cube cancels what? Cm cube. So 1 times 300 is 300. 300 divided by 1000. That's what we're looking for now. That's 0.3. So x dm cube is now equal to 0.3 dm cube. So what we just did is very simple. Hope you are following me. All these things are simple. They are not difficult. In summary, whenever you are converting from cm cube to dm cube, all right, you must know this conversion. 1 dm cube is equal to 1000 cm cube. And bring whatever you are giving down and do the math and follow instructions. But in summary, you are converting from cm cube to dm cube. Divide by 1000. That's the summary. So basically, 300 cm cube basically is now same as, all right, is equivalent to, is now same as 0.3 dm cube, because this is what we actually need to impute in our formula to get our answer without stress. We don't need our values to be in cm cube because this constant does not work with volume being in cm cube. Hope you are following me. All these things are very simple. Okay, guys, you can see we've worked for volume conversion. Let's do same for pressure, because we're converting 700 now to atm. All right, you can see it here. So let me teach you how to convert from millimeter mmHg to atm. Is very, very simple. Okay, guys, moving further, let's go over to convert 700 mmHg to 700 mmHg, all right, to ATM. Very simple. So basically, what do? You have to know the conversion factor that relates both parameters. You should know here that 1 ATM, 1 atmosphere, is equal to 760 mmHg. So then we are looking for our answer or our value in ATM. So x ATM will not be based on what they give to us. Hope you understand. Always write the conversion first, or write down what you are giving and what you are looking for. All right, is equal to what? 700 mmHg. Hope you are following me. All these things are very, very simple. So basically, making x ATM subject formula is very simple. So basically, hope you understand how to make something subject formula now. You times this one, divide by here, times this first. You are making this subject, you times this side and divide by this one. You understand? I can still take it step by step, but basically times this and divide by this. So 1 times 1 ATM, all right, times 700 mmHg. All right, just follow instructions, are very simple, divided by 760 mmHg. So what do we have for x ATM? So basically 1 times 700 is 700. So 700 divided by 760, that's 0.92. So 0.921 ATM. So 700 mmHg is equivalent to 0.921 what ATM. So you can see the correct units we have to use to solve in our formula to get our answer without stress. Alright guys, moving further, we are not yet done. We must make sure that our temperature is converted to Kelvin. Alright, you should know this conversion factor, that Kelvin temperature, K, is equal to degrees Celsius plus 273. So basically, what do we do next? So Kelvin will not be equal to what's degree Celsius is 27, all right. 27 plus 273 was that 300, all right. So 27 plus 273 was that. So what becomes Kelvin? Kelvin becomes 300 Kelvin. We're not using 27 to solve. So basically, imputing all of these new parameters we've gotten into our formula for number of moles. So number of moles now be what's the pressure is now 0.921 atm, all right, times what's the volume? It is 0.3 dm cube divided by, all right, what's the R, the molar gas constant? I've given to you already, 0.08205 times what's the Kelvin temperature? It is 300. Don't use degree Celsius temperature. All right, imputing all this into our formula we are having, all right, 0.921 times 0.3 divided by 0.0205 times 300. That is, wow. So we're having number of moles n to be what? 0.011225 moles. So basically, this is how this question was solved without stress. So follow instructions. All these things are very easy. So get ready for your own practice question, which is question number 12. And I'm going to change the parameter. So you have to look for number of moles. So here it becomes 500. And here exactly the pressure of 710 mmHg. And here is at room temperature. At room temperature. So basically, whenever you see room temperature chemistry, you should know here that room temperature is a value and it's 25 degrees Celsius. All right, so you can now use 25 degrees Celsius to get for your Kelvin temperature. Hope is understood. So this is your own practice question, which is question number 12. All right, so we'll get into the next practice question. Okay, guys, let's get into the next practice question, and it says, what is the number of moles? Wow, we are still asked to get number of moles of 5.6 dm cube using dm cube, that is volume, of SO2 gas, all right, at STP. Let me just tell you something. Whenever you're solving questions, because we are still on part 1, whenever you're solving questions and they're asking to get number of moles, and you saw STP in the question, STP here simply means standard temperature and pressure. There is a formula for number of moles that has to do with STP, and that formula is number of moles is equal to volume at STP, all right, divided by 22.4 dm cube. So definitely the unit of my volume here up will be in dm cube as well, because you must ensure that the units you're having up and the units you're having down, they are literally the same. We can also write this formula in another format based on how questions come. So number of moles can also be volume at STP, all right, volume at what? STP, all right, divided by 22,400 cm cube. So let's say basically in that, so definitely up here will not be in cm cube. So what does this tell us? Because it tells us that in solving questions under this aspect, volume at times in the question can be in dm cube or cm cube. So if it's in dm cube, use the up formula. If it's in cm cube, use the down formula. So based on this question, which of the formula are we to use? You can see that it's similar to that second formula we solve questions on. So we have to use this formula, which is number of moles, not be volume in dm cube, which is 5.6 dm cube, all right, divided by what? 22.4 what? dm cube. Don't go and use this down one, no, because if you divide by 20,400, you won't get the answer because the volume was in dm cube. So use the correct formula for questions. So basically, what do we do next? It's very simple. It's now become 5.6. All right, 5.6 divided by 22.4. That's 0. All right, 5.6. That's 0.25. All right, 0.25. And what did we just get in the n, which is 0.25 moles? Hope is clear. It's very simple. Meanwhile, in solving questions like this, please, you are not using the compound. Don't go and say, oh, I should calculate molar mass. No. When it comes to the time where I'll tell you how to calculate molar mass, don't worry, I don't have to say much now. But here's your own practice question, making it question 14. What is the number of moles of, let's change the volume now to, let's say, 230, all right, cm cube. 230 cm cube of not this gas anymore. Let me just change to ammonia, NH3 at STP. So solve this question and provide the answer in the comment section. So we'll get into the next practice question. which is question number 15. All right, which is question number 15. Let's get into question number 15, and you can see that we've analyzed this formula. Let's get into the last, because this is the fourth. Let's get into the last formula and then progress to part 2 of this lesson. Okay guys, let's get into the next practice question. You can see now that this question, we are still looking for number of moles, but the format of the question has changed because we are not to use those formulas. Here's the last formula. All right, so after understanding from formula 1 to formula 5, which is this question, we can now progress to part 2 of this lesson. So the question says calculate the number of moles. We are still looking for n, all right, present in 2.06 times 10 raised to the power of 23 atoms. All right, so just listen. Whenever in a question you just see atoms and they say calculate number of moles, you saw atoms, calculate number of moles. There is a formula you should note, and that formula is simply number of moles is simply number of atoms, listen, number of atoms divided by a constant in chemistry called Avogadro's constant. And what is that constant? It is 6.02 times 10 raised to the power of 23. Hope you are following me. So basically, let us progress. So what becomes the number of moles? What's the number of atoms they gave us already? To be 2.06 times 10 raised to the power of 23 divided by 6.02 times 10 raised to the power of 23 as well. So basically, you already know that, okay, 10 raised to the power of 23 can cancel 10 raised to the power of 23 because they have the same power, you get. And now number of moles will now be 2.06 divided by 6.02. That is we are having number of moles to be 0.3422 moles of what? Chlorine. But there's something I have to tell you that is very important. All right, in solving questions on this aspect, this place we are having number of atoms can be changed to number of particles. Listen, can be changed to number of particles. You can, because now they can just put this number 6.02 times 10 raised to the power of 23 particles. It's still the same format you have to use. This way we're having number of particles can even be changed to number of molecules. So basically 6.02 times 10 raised to the power of 23, it can also be called molecules. You get that we having atoms, we can remove it to be molecules. Even that same number can be changed to ions as well. You can just call it 2.06 times 10 raised to the power of 23 ions. So you see, change it. But basically, based on definition, they are not the same thing. Molecules is different from atoms, you get. But I'm just telling you for the sake of calculations, they can remove that place to the atom and put molecules. They can remove it to the atom and put particles, you get. Even ions as well, but it's same formula you are still to use. You write anything here based on what you are given, divided by Avogadro's constant, and then solve. So basically, this question brings us to the end of part 1 of this lesson. So your own question will not be, let's say, 4.06 same or power, and then you solve the question. So we are done with part 1 of this lesson. So let's get straight into part 2 of this video lesson.
To have more understanding about chemistry calculations and solving all of this type of questions, I already have them on the chemistry masterpiece, okay, which is calculations and keynotes in chemistry. So if you are preparing to write the JAM exam, this book is very, very important for you. Now, for more information getting the chemistry masterpiece, do well to direct message me via my WhatsApp number. It will be on the screen.
Okay guys, let's get into the next practice question, and this question starts part 2. Now let me explain the overview on part 2, how to solve questions. Though I'm not ready, but now in solving questions under this aspect, we will not be asked to calculate for number of moles anymore. Now we will not be asked to calculate for those parameters inside the formulas for number of moles, e.g. mass, e.g. volume, concentration, number of atoms. All those formulas we saw, pressure, temperature, will be asked to calculate those things, you get. But now, so now in this aspect, we relate formulas. In this part 2, we are to bring formulas together, and the maximum number of formulas we have to bring together is 2. So in solving any question on this part, any question I'm going to bring next, we'll be relating 2 out of the 5 formulas. So read our question very well. Look at, oh, this question requires us to use that first formula I used to solve question, also require us to use the fourth formula, also requires us to use third. So basically, it's just to bring those formulas together, you are relating them together. Once I solve this question, I'm going to give you more practice example so as to master part 2. Part 2 is very, very simple. Same applies to part 3, which we will actually get to. You get. So just watch closely. So basically, before we solve part 2, if you find my video lesson helpful, make sure you click on the subscribe button to my channel and also share my lessons to friends, because it will help you all improve greatly in chemistry, specifically in this aspect of chemistry. So the question asks, what mass, all right, of sodium hydroxide, what mass, I'm not going to say much, all right, of sodium hydroxide, NaOH, is sodium hydroxide. Are you there? Present in that volume, 500 cm cube of this value, 2 moles per dm cube. I know you're already having something in your mind that, okay, I told you guys that we are relating 2 formulas, so, and I believe now you are thinking the formulas that you have to bring together to solve this question, because they are asking what mass. So definitely we must use the first formula I gave to us, which is number of moles is equal to mass divided by molar mass. I gave us this formula now, which is the first formula we started with solving questions under this aspect, because in this question they asked us to calculate mass. So definitely we need this formula, and then present in 500 cm cube of 2 moles per dm cube is very simple. You know, that is volume and this is concentration. So definitely must use the our second formula we use to solve question. And what was that formula? It is number of moles is equal to concentration, all right, concentration times volume. Now what's the unit of this volume? The volume was a cm cube. So cm cube. So should I do, guys? So what should I do, guys? You already know that, okay, when volume is in cm cube, we divide by 1000. Hope you are aware now. Hope you've not forgotten this simple thing. If the volume was in dm cube, I will not divide by 1000. I'll divide by 1 or divide by nothing. You get. Remember I said that part 2 has to do with relationship. So basically, we've gotten number of moles equals to this formula, which is the first, because we're asked to get mass, so we need it, and then because of the parameters given to us, we also need this formula, number of moles equals to this. So you already know that, okay, number of moles definitely is equal to number of moles. That means these 2 formulas will be equated together. So definitely I'm going to equate these 2 formulas together. Hope you are aware. So when I do that, what should I get? Look at. So we're having mass, all right, over molar mass, which is the first number of moles, all right, is equal to this other one, which is what? Concentration, all right, is equal to concentration, all right, times volume in what unit? Cm cube divided by 1000. Hope you are aware, it's very simple. So we have to make mass subject of formula. Making mass subject of formula, what do we do? Listen, we have to make this subject of formula, everything here with times. So first of all, we have to cross multiply. So everything here times remaining this, will divide by this. Hope you know now. To make mass subject, everything here with times divided by 1000. Hope you are aware about that. It's simple. So basically, what do we have? Mass will now be, all right, molar mass, all right, molar mass times concentration, all right, times concentration times volume in what unit? The cm cube divided by what? 1000. So what becomes mass, everybody? What's the molar mass? Sodium hydroxide, first of all, NaOH. We have to calculate the molar mass of it. So definitely there are 3 elements here, which is sodium, all right, oxygen and hydrogen. Sodium atomic mass is 23. I think we've talked about that initially. Oxygen is 16, hydrogen is 1. So basically, calculating molar mass, it becomes 23 plus what? 16 plus 1. When we hit everything in our calculator, we are getting 40 grams per mole. Hope you are aware now. So 23 plus 16 plus 1, that's 40 grams per mole. So basically, molar mass here becomes 40. All right, 40 grams per mole times concentration, which is 2 moles per dm cube. So times 2 times the volume, which is 500 cm cube. All right, 500 divided by 1000. So when we hit everything in our calculator, let's see the mass we have to get for the compound, which is sodium hydroxide. So we are having 40 times 2 times 500 divided by 1000. That is 40. Wow, I still had mass to be 40 grams. So class, you can see how questions under this aspect are being tackled without stress. They are all very easy. Practice makes perfect. So get ready for your practice question. Remember, on this aspect of question, you will not be asked to get number of moles anymore. You will not be asked to get all those parameters inside the formula. So next, I think this is the last thing I'll do in this aspect. Do you understand? This is the last question I'm solving in this aspect. Why? Because it's for you to master it. So I'll write some questions here. So your question will be question number 18. All right, question number 18 will still be on this aspect. So this question 18, what is the mass of? Let me change the compound to now be, let's say, H2SO4 present in, let's remove this and put something like 60 dm cube. All right, you see, seeing 60 dm cube, I believe what comes to your mind of this same concentration. So you seeing 60, you know that you are not to divide by 1000 here. Oh, don't make that mistake and go and divide by 1000. So this is your own question first based on this aspect. So H2SO4, here is the atomic masses of the element. So basically, SO4. So basically, hydrogen is 1, sulfur is 32, oxygen is 16. All right, these are the information you just need to solve this question. So let's get into the next question, which is question number 19, and it's for you. Even question number 20, and it's for you as well. Even 21 is for you. Based on this aspect, it's just for you to look at the question very well, relate all those formulas. You can do it, you can actually solve it. All right, let's get into those questions and then get to part 3, solve many questions on part 3, and we are done with this aspect, and you're already good with this aspect. All right, so let's progress.
To have more understanding about chemistry calculations and solving all of these type of questions, I already have them on the chemistry masterpiece, okay, which is calculations and keynotes in chemistry. So if you are preparing to write the JAM exam, this book is very, very important for you. Now, for more information getting the chemistry masterpiece, do well to direct message me via my WhatsApp number. It will be on the screen.
Okay guys, moving further, these are your own practice questions under this aspect, which is part 2 on relating 2 formulas out of the 5 formulas I gave to us. So you can see from this question, question number 19, it says, what is the mass? So in this question, they are asking us to get mass. Listen carefully. They are asking us to get mass. So you think about that formula that has mass for number of moles, which is number of moles is equal to mass over molar mass. So that formula that has mass in that formula, you take it, you take note of it, you bring it out. So because they're asking to get mass present in 2.6 dm cube of SO2 at STP. Remember, I told you whenever you hear STP, there is a formula that should come to your mind. And what's that formula? Is number of moles is equal to volume at STP. Let's say the volume. So based on the volume given to us is in dm cube, we divide by what now? 22.4 dm cube. You understand? So basically, since the ask us to get mass, then we'll use the formula which is number of moles is equal to what? Mass divided by molar mass. So since this aspect is not on calculating number of moles, it's on relationship, then you relate both formula together. Mass over molar mass is equal to this formula, volume over 22.4 dm cube. You relate them together and you make your mass subject. How do you get a molar mass? They gave you a compound here to calculate molar mass, and then you have to know the atomic masses of these element forming the compound. Like the first element here I'm seeing is sulfur, and sulfur atomic mass is 32, oxygen atomic mass is 16. I believe you know that already. So you can see how solving questions on all of these aspect part 2 are made so easy. From the first example I give to us, I believe you can solve all these questions, solve them and provide them in the comment section. So all this must be noted. Same also applies to the next question, and it says calculate the concentration. So in this question, they told you to calculate concentration. You have to think about that formula that has concentration in it. And what's that formula? It is simply number of moles is equal to concentration, all right, times what? Volume. All right, if the volume is in dm cube, so basically now you can see they gave us volume in this question and the volume was in cm cube, then we are to divide by what? 1000. You understand now? So calculate the concentration of sodium chloride. All right, they gave a compound. Then since you are seeing this compound, then I believe you know that whenever you are given a compound, then you have to calculate molar mass of that compound. And also they said present in 20 grams. Is a confirmation that we are still to use this formula. So in this question, we are relating this and this formula together. Hope it's clear. It's very simple. Practice makes perfect. Same applies to this question. Okay, question number 21 says the volume of All right, so question number 21 is it's actually on part one. Why? We saw moles. You know, I told you on part two, do you not be saying calculate moles or you not see anything like moles? So since we saw moles, so then asking us the volume of 2.5 moles of oxygen gas at STP is what? So basically, since you saw STP and you saw moles, definitely you are using that formula, which is number of moles is equal to volume at STP and volume. Okay, now you can decide to use any units. All right, so let's just use the one that has dm cube divided by 22.4 dm cube. So then I said the volume, meaning that they asked us to get the volume. So what do you do next? You make the volume subject of formula. Making this subject is going to be n times this. You understand? So what's the number of moles? 2.5 times 22.4 dm cube. Here you are not calculating any molar mass, so because you were not giving mass, they just said the volume. I already told you the trick to learn how to solve questions on part one. Part one, you will see moles, or they will say calculate for the moles. So then you know that, oh, it's part one question, or it's part one formula you have to use, whereby you just pick the formula and use it. But for part two, you are relating formulas together. All these things are very easy. Same applies to question number 22 and question number 23. Is still the same approach. So question number 22 says a sample of an unknown gas. The gas is unknown, all right. Then I told us it has a mass to be this, and it occupies 5 dm cube, that's volume, at 1 atm, that's pressure, at 273 Kelvin, that's temperature. What is the molar mass of the gas? This question is simple. You already know the question. You already know what to do. Even if you do not see ideal gas, please note this. This is volume, this is pressure, this is temperature. Out of all those formulas I give you, which one carries these three parameters together alongside arrow? It is the formula that says, for question number 22, that says number of moles, all right, listen carefully, is equal to PV divided by RT. All right, because now in this question, they say, what is the molar mass? So definitely we are still to use this formula. So it's going to be a relationship between this formula and this formula you bring them together and make molar mass subject. They've given us the mass already to be 10 grams. So mass here will be 10 grams. You understand? You are relating this and this together. This question is very simple. Let's get into the last question. Make sure you provide the answer to these questions in the comment section. Solve carefully. Okay guys, now here is question number 23. Listen carefully. It says a sample of N2, which is nitrogen gas, all right? Remember, nitrogen basically is symbolized as N, and basically the atomic mass is 14. Listen carefully, because you actually need all of this to solve this question. Just listen. So they said that a sample of nitrogen gas, you understand, when it's N2, you call it a gas. Nitrogen gas has a mass of this 14 grams. How many atoms of nitrogen are present? Very simple. You can see now you had atoms. So then you must relate that last formula we solved with the first formula as well, because you saw mass. So mass over molar mass will now be related to that formula that says number of moles is equal to what now? Number of atoms, because you had atom in this question. Number of atoms divided by Avogadro's constant, which is 6.02 times 10 to the 23. You understand now? You relate this and this. You understand? And make number of atoms subject of formula. And then you already know what to do. But basically, you should be careful. For in you calculating your molar mass, you can see it's N2. N2. It is not just NO. So don't just say molar mass is 14. Make sure you say 14 times 2. You understand? And get your molar mass and solve carefully. Make number of atoms subject, because they said how many atoms, and then you get your answer without stress. All right. I'm waiting for you to provide the answers to all of these questions and more questions we've talked about initially. So we can go over to the last part of this video lesson, which is part 3. So get ready.
To have more understanding about chemistry calculations and solving all of these type of questions, I already have them on the chemistry masterpiece, okay, which is calculations and keynotes in chemistry. So if you are preparing to write the JAM exam, this book is very, very important for you. Now, for more information getting the chemistry masterpiece, do well to direct message me via my WhatsApp number. It will be on the screen.
Okay guys, moving further, let's get into the next practice question, which is question number 24. Now, this question is extremely very easy, and this is the question we are using to start part 3. Now, let me explain the overview of part 3 so you understand perfectly what is about happening now. For part 3, it has to do with stoichiometry of reactions, whereby in questions on this aspect, you will be giving reactions all the time in the question. All right, you can see that in this question we're given a reaction. And now let me explain how it works. In this aspect of chemistry, specifically stoichiometry of reactions, we relate two things. Listen, we relate what? Two things. Not, we don't relate two formulas, we relate what? Two things. And what are these things we relate? What we are given and what we are asked to calculate for. Listen, I'm going to explain. I repeat. In this aspect, we are relating two things. One of them is what we are given and what we are asked to look for. That's the thing we are relating, and that's what this aspect of chemistry talks about. You know, in this aspect, I'm going to solve so many practice questions so you understand them properly without any stress. So pay close attention to the way we'll be solving all of these questions right now on part 3. And if you've not yet subscribed to my channel, make sure you click on the subscribe button to my channel and also share my lessons with your friends. All right, so let's get straight into the question. The question says, calculate the number of moles of oxygen. This question is simple. Relax. I know you saw number of moles and you might be thinking, relax. This is a different aspect. Calculate number of moles of oxygen. So basically, in this question, they are asking us to calculate number of moles of oxygen. And what is that? They are asking us to. So remember, I told you on this aspect, we are interested with two things: what we are given and what we are asked to look for. So in this question, what are we asked to look for? Is oxygen, something for oxygen. And to be specific, they said number of moles of oxygen. Because as we progress in solving more questions, I'm going to change all of these things to look for different things, and I will tell you how it works. And all of these things we are looking for all boils down to those 5 formulas we already know. You get. So basically, once you've noted what you are asked to look for, you go to your reaction and identify it. So basically, we are asked to look for something for oxygen. I will identify oxygen. Are you there? I've underlined oxygen. Remember, it's 2 things we are interested in. We've seen what we are looking for. So let's look for what we are given. All right. So they say calculate the number of moles of oxygen produced. Oxygen was produced. This sign shows that oxygen was produced from the decomposition of 4 moles of KClO3. This is KClO3. Decomposition means breaking it down with the help of heat, you understand? So basically, we were given something for KClO3. So this is what we are giving. Are you there? 4 moles of KClO3. So in summary, I've identified the 2 things we're interested in, what we are asked to look for and what we are giving. Do you understand? That is how it works. In solving this question, this is the method you should use for solving more practice questions under stoichiometry of reactions, and they are all very easy. So after you have successfully identified those 2 things, you bring them down. You bring them down from the reaction the way they are written. So you can see here I'm having 2KClO3, all right, to give me, all right, you bring oxygen down to 3O2. That's how it works. Even if, for instance, both of them were in the same place based on the reaction, like let's say, for instance, oxygen was here, based like KClO3 plus oxygen, like based on how different reaction can exist, you understand? So I'm just telling you now, for instance, if this oxygen is here, for instance, you still bring them down, but you separate them the way it is. You understand? So after you've done this, write down their stoichiometric ratio. This is what I mean. The 2 moles of KClO3, write it down. So KClO3 here becomes 2 moles. Are you there? All these things are very easy. So basically, because of 2, I wrote 2 moles here. So now give me for oxygen, what's the moles? 3 moles. Are you there? So that's what you should do. Please listen. Remember, we are asked to look for number of moles of oxygen. We have to get the number of moles of oxygen. So here become X moles. So you should now write X moles under oxygen. Please note all this. And then go back to your question and look for what they gave to you for the KClO3 initially. And they gave you 4 moles initially. You understand? So in summary, after you identify them, bring them down, write first their stoichiometric ratios, and then bring down whatever you are looking for, and what you are giving, bring them down. You understand? Make sure you bring them down based on how the question told you. You understand? They said for oxygen, so we'll put X mole for oxygen and 4 moles for the KClO3 because that's what they gave us initially. So what becomes next is cross multiply. So what becomes X mole, everybody? X mole of which gas? Of oxygen. All right, let's just say X mole will not be making this subject going to be 4 times 3. 4 times 3 divided by 2. You understand? 4 times 3 divided by this. So what becomes X mole? X mole become 4 times 3, that's 12. Divided by 2, that's 6. All right. All right, so 6 moles of what? Oxygen. So this is the answer to the question. Is very, very simple. It is not difficult. So basically, this is the first question. I'm going to give you a practice question. Then we'll go higher to solve more practice questions under stoichiometry of reactions, and they're all very easy. So here is your practice question. All right, calculate the number of moles of oxygen still produced from the decomposition of water, but basically, let's say 3 moles, all right, 3 moles of water, 3 moles of water, H2O. So what this means that water have been broken down. So when we break water, what do we get? Very simple. We get hydrogen gas and as well oxygen gas. You're like you're breaking it, you get hydrogen and oxygen gas, but the reaction is not balanced. So if you are finding it difficult to balance reactions, I already have a full video lesson on my channel that explains that. So after watching this lesson, make sure you go watch this video on your screen now, so you master this aspect. I'm going to teach you how it's done. Hydrogen here is 2, but in that lesson I explained it step by step. Here I want to just quickly balance it. Hydrogen is 2, hydrogen is 2, so hydrogen is balanced. Oxygen here is what? 1. Oxygen is 2. So what do we do here to balance? We'll put 2 because you putting a number at the front, it affects everything. So the 2 has affected oxygen, 2 affected hydrogen. So here now we're having 2 oxygen. But here 2 oxygen. But hydrogen has increased the number because here now be 2 times 2, 4. So basically I should put 2 here to balance hydrogen as well. So basically the reaction is balanced. But it is best for you to go watch my full video lesson on how to balance chemical reactions without stress. All right, I've made a video lesson that explains everything from scratch to mastery. All right, so here now, remember the rule. You are calculating number of moles of oxygen gas, so you identify oxygen. In other cases, not just oxygen. This is your practice question. That's why I'm doing this. So this is question number 25, and then they gave you 3 moles of water, so you bring them down. Please take note, whenever you're not seeing any number standing in front of a compound or element, you'd say that, oh, there is an invisible one. So when you brought them down, it's going to be 2 moles to give you how many moles of the oxygen? 1 moles based on this reaction. Just follow instructions and solve it without stress. So let's go higher in solving questions under this aspect without stress. They're all very easy. Get ready for the next practice question. This is your own. Let's go over to the next practice question. Okay, guys, moving further, let's get into the next practice question. This question is extremely very easy. So let's get into the question. The question says, what is the mass of iron? So remember, on this aspect of part 3, we are interested with 2 things. What are they? What we are asked to get for and what we are giving. So basically, they said, what's the mass of iron? So basically, iron is Fe. So we take note of this iron that would be required to react with something, to react with 0.025 moles of HCl. So definitely we are relating it with both of them. I told you whenever sometimes we have them in the same side, you still separate them and bring them down. So bring them down based on how they were reaching the reaction. So Fe will give me 2HCl. Separate them. Are you there? What's the next step? Write down their stoichiometric ratio. Here you are seeing an invisible one here. So here become 1 moles. All right. To give me what becomes here? 2 moles. Are you there? So what becomes the next thing to do is very simple. The next thing to do is now to take note of what you're looking for. Remember, in this question, they're asking us for mass. I am aware. But in stoichiometry, the basic unit of stoichiometry is moles. That's why I always make sure that they are in moles first. And at the end of getting my moles, I'll convert it to mass based on our knowledge on part 1 and part 2. So you just relax and listen carefully. So basically, you know that the basic unit of life is a cell. So the basic unit of this stoichiometry is moles. So without moles, we cannot get any other thing. So that's why we must try to get moles first. I know they're asking me to get mass. I cannot just say X mass. No, don't do this. It's not correct. Right here, X moles. Are you there? Will not give me, all right, the moles given to us for the HCl based on the question. And I told you, you're interested with 2 things, what you're asked and what you are giving. This is what we are giving now. And we're giving 0.025 moles of what? HCl. So then we cross multiply to make X mole subject. So making X mole subject, what we have? We get 1 times this, all right? All right, 1 times 0.025 divided by 2. So basically, what becomes X moles? All right, X mole will be 1 times 0.025 divided by 2. That is 0.0125. All right, 0.0125 moles of what? moles of what? Iron, Fe. So basically, this is not the final answer because the question says, what is the mass? So what you have to do next is to convert this thing to mass. It's very simple now. I've given you guys the formula initially in part 1. How do you convert a value from moles to mass? Very simple. Use that your first formula, which is number of moles is equal to what? Mass divided by molar mass. So then what happens next? Make your mass subject. Making mass subject of formula. What do we have? We have a number of moles times this, n times what? Molar mass. So then the element is iron. So you have to know the atomic mass of iron. The atomic mass of iron is 56. So what becomes the molar mass? Is still 56. Just add grams per mole. So I told you all this initially now. So then what are we having? Mass will now be equal to what's the number of moles? 0.0125 times, that's moles. All right, let's write it moles. Moles times the molar mass 56 grams per moles. You understand? Mole cancel moles. So what becomes mass? Mass will not be 0.0125 times 56. That's a 0.7, all right? So mass becomes 0.7, what's remaining? Grams. So 0.7 grams is the answer for the mass of what iron required to react with this to form this product. So that's how I solved. Get ready for your own practice question. This question is very, very simple. Okay, guys, here is your own practice question. So you solve and provide the answer in the comment section. You can see I've changed the reaction, I've changed the elements. So you look for, I believe you already know what you're looking for. So let's get to more practice questions under this aspect. Just understand this basic rudiments. That's all you need. But let's progress to solve more and more practice questions. All right. Question number next. This question number 27. So let's get straight into question number 28. Okay, guys, let's get into the next practice question, and it says from the equation above. All right, they gave us an equation and it is balanced. Equations are also called reactions. Calculate the volume of oxygen. Wow, we are interested with oxygen. Underline it. Take note of those two things you are interested in first and bring them down, and then now solve the question. All right. Calculate the volume of oxygen. I know we are asked to get volume, leave that alone. And volume of oxygen at STP, where they were specific. Volume at STP, all right, that is required to react with 0.0045 moles of butane. So basically, this is butane, C4H10. Butane is an organic compound. So understanding the concept of organic chemistry is very key. So if you are here finding it difficult to learn how to name organic compounds, I already have a full video lesson on my channel that explains that. Here's the video. So go watch this video after you're done watching this particular video lesson on stoichiometry. So basically, required to react with 0.045 moles of butane. So basically, we're in charge with these two things. We'll bring them down. So 2C4H10. So give me what now? 13O2. You understand? You know the normal. So basically, after you are done, you write out the stoichiometric ratio. So 2 moles of this to give me what? 13 moles of oxygen. So then for this, remember we're looking for volume of oxygen at STP, but make sure you write X mole first. So what becomes next? What's the mole given to us according to the question? 0.045 moles. So then what happens next? Cross multiply. What becomes X moles? X moles will now be equal to this times this. So 0.045 times 13 divided by 2. All right, divided by 2. So what becomes X moles of oxygen? Let's enter all of these parameters into the formula. Into the calculator, we have 0.0045 times 13 divided by 2. That is, I had X moles of oxygen to be 0.02925 moles of oxygen. Now, this question is simple because now they are not asking us. We are not asked to get the number of moles of oxygen, which we just did. We are asked to get the volume of oxygen. Volume of oxygen at STP. Remember the formula that has volume at STP now? That's the fourth formula. Yes, based on part 1. And what's that formula again? Number of moles is equal to volume at STP. It can be in dm cube or cm cube. Let's make sure it's in dm cube now. Divided by 22.4 dm cube. All right, volume at STP. So we are looking for volume. What becomes volume? The same approach. All these things are very easy. Volume in dm cube will now be equal to n times what? 22.4 dm cube. So basically, what becomes volume in dm cube? All right, volume in dm cube will now be, what's the n we've got? In 0.02925 moles all right, times 22.4 dm cube. So basically, what becomes volume, everybody, listen carefully, in dm cube is going to be when we hit our calculator, that's 0.002925, all right, times 22.4. What we got volume? I'm having 0.6552 dm cube. This question is extremely very easy. Just pay close attention. You can see how this question was tackled. Let's go higher a little. Let's just let me just change the question from the question above. Calculate the volume of oxygen required to react with, let's say I'm going to give the same reaction. All right, let's say now this time around, we're having, let's say, 0.5 moles of butane. So just solve this question. So basically, here that was this. I just changed to 0.5, and let's see what you get. And provide the answer in the comment section. They're all very easy. Let's go higher in solving questions under this aspect. Okay, guys, moving over to the next practice question, which is question number 30. It says, they gave us a reaction, and the reaction is balanced. Whenever you're solving a question on this aspect, always ensure that the reaction is balanced. In some questions, they will give you the reaction unbalanced. Unbalanced, as the reaction is not balanced in some questions. So basically, you must try to balance it. That's why you should learn how to balance reaction by watching this video here. If you don't know how that is done, it's very simple, but most of the time the reaction will be balanced for you. But always ensure that it's balanced. Always check if it is balanced. And from the look of things, this reaction is balanced. And what does the question say? It's very simple. It says, we've done so many questions on that aspect. It says, using the equation above, calculate the volume of CO2. So basically, you take note of CO2 measured at STP. Wow. We are looking for volume of CO2 at STP. I didn't know the formula in my mind. That formula that has number of moles equals volume at 30 at STP over 20.4 dm cube. I'll use that formula at the end. But relax, is the volume we're looking for. Relax, all right. Produced. It was produced when 53 grams of this. Wow, they gave us something for this. I'll just take note of it. 53 grams of sodium trioxocarbonate 4. Sodium trioxocarbonate 4. So basically, what do we do next? 53 grams of Na2CO3 react with hydrochloric acid. It's very simple. You can see that we're interested in, I told you where they gave you parameter for, that's what you are underline. Don't go underline ACL. Did they give anything for ACL? No, they gave you a number for Na2CO3. So you take note of this and the other. So basically, you bring them down. So basically, it's actually Na2CO3, all right, to give you CO2. You can see they don't have a number, so you make them 1 moles of these to give me how many moles? 1 moles of these. So basically, you should be careful. You can see from the question, they gave us 53 grams of Na2CO3. Remember, initially it was moles. Now they gave us in grams. Convert it to moles before you bring it here. Don't go and write 53 grams because they say, yes, 53 grams. You gotta write 53 grams and then is equal to X moles. Don't ever do that. Because basically, I told you that they must all be in the same unit. Is it easy mole? No, you must make sure that easy moles. You understand? So you must convert 53 grams of Na2CO3 to moles first. This is how it's done. So basically, Na2CO3, so 53 grams of Na2CO3 to moles. How is that done? Remember, you saw grams, you must use the formula, which is number of moles is equal to mass divided by molar mass. So then, what becomes number? What's the mass? 53 grams divided by molar mass. You have to calculate the molar mass of this compound. Here it is. Just watch. I'll wipe the board. I'll wipe the part I solved it. So Na2CO3, just listen. So molar mass will not be, I've written molar mass. Molar mass will not be equal to, what's the atomic mass of sodium? 23, something you should know. But you'll be given 23 is the atomic mass of sodium, all right, times, so we have 12 of it, so times 2 plus, we've done this many times now. So carbon is 12 plus oxygen is 16 times 3. So when you hit your calculator, definitely the molar mass become 106 grams per mole. Hope you are following. They're all very easy. So molar mass become 106 grams per mole. So what become number of moles when we hit our calculator? So 53 divided by 106 gram per mole was that 0.5 moles. So we had 0.5 moles of what now? This same compound of what now? Na2CO3. Most of the time, initially before, they will give us moles. Now they change it to being grams. You don't have to be bothered about what they will give to you. Anything they give to you, always make sure that. That's why you must master those 5 formulas. They can also change this thing to being like concentration volume format. So you see, use that second formula that is concentration times volume the volume is in cm cube divided by 1000 to convert to moles first and then bring it here. So basically we have 0.5 moles of this compound to now give us x mole. Hope that is clear. It's very simple. So x moles will now be equal to, or this times this, all right, 0.5 times 1 divided by 1. You understand? So what are we having? 0.5 moles of which compound now? Of CO2 now, because they said calculate the volume of CO2. So basically of CO2. Remember, what are we looking for in this question? Is it moles? No. Remember, in this question, we are asked to get for volume. Volume, that's what we are asked. Volume at STP. So basically, you should remember the formula for that says number of moles is equal to volume. Let's say the volume is in cm cube now. I just changed to cm cube. So you know, if I change to cm cube at STP, I'm going to divide by 22,400. If it was DM cube, it will become 20.4. I can use any of them. So basically, that's how it works. You know, in your exam, if your exams are optional exams, so if you see that the volume in the options are in DM cube, you use DM cube. If you see that the volume is in the options are in CM cube, you use this one. You understand what I'm saying now? So basically, what becomes volume? Volume will now be equal to number of moles times 20.4. No, not 20.4 now. 22,400 cm cube. You know, volume is in cm cube. Oh, don't make this mistake. It's very simple. So volume is in cm cube. So volume in cm cube will now be words. What's the number of moles? 0.5. All right, 0.5 times 22,400. All right. So what are we having? Volume in cm cube. What becomes it? 0.5 times 22,400, that's 11,200 cm cube. I hope this is clear. It's very simple. All these questions are very simple. So if it's in dm cube, you already know what to do. That's what it. If the volume, like let's say the volume in the options are in dm cube, use the one that is in dm cube. Use the format of the formula in dm cube, where here will be divided by 20.4, and this will be same to be in dm cube. That's how it works. They're all very simple. So here is your own practice question, question number 21, whereby I'm gonna just change the parameter. Here will be, let's say, when just follow instructions, when 100 cm cube of 0.5 moles, all right, moles per dm cube, Na2CO3. So basically, you know what's happening here. You can see the parameter given to you now is different. It doesn't have mass in it. It has volume and concentration. So definitely here, you will now use that formula that says number of moles equal to volume, concentration times volume over 1000. You understand? Volume was in cm cube. So then you don't need to calculate molar mass. Hope you understand what's happening now. So I'm just telling you that there are various ways questions can come. So it's just for you to understand those 5 basic formulas that matters here. You get, they're all very easy. So I believe you can solve this question. Let me see. You can solve it. You can solve it. I believe in you. You can solve the question. So solve this question and provide the answer in the comment section. Let's get into the next practice question, which is question number 32. All right. Okay, guys, let's get into the next practice questions. You can see them on the board. And these questions, you'll be the one to solve them. I won't solve them. I will just guide you. They're all simple. You can see for the reaction, they gave you a reaction, and the reaction is balanced. The questioner says, calculate the volume of nitrogen. This is what you're interested in. Volume of nitrogen at STP. So you already know the formula you have to use at the end of solving the question. All right, from 3.2 grams of this. So basically, this is the compound. Don't get confused. Dioxonitrate 3 salt. This is it. I'm telling you, if you don't know it, this is it. Sometimes you can just write it the way it is or write the name. So you should not get confused. This is the compound. So in this question, you're relating these two guys to bring them down. You understand? So 1 mole of this give you 1 mole of this. Then you convert this to mass. So definitely, let me give you all the atomic masses. Nitrogen is 14. Hydrogen is 1. Another nitrogen is 14. And oxygen is 16 atomic mass. Please solve the molar mass correctly. You don't have to rush it. You simply say 14 plus 1 times 4 plus another 14 plus oxygen, which is 16 times 2. Solve the molar mass correctly. You get the answer. Solve it. I won't solve it. You have to do it yourself. So master and put the answers in the comment section. Let's get into the next. You are still to solve it. How much magnesium? Whenever you see how much of something, it means they're asking to get mass. But basically, what they're asking us majorly is dependent on what we have in the option. You understand? But me now, I'm telling you, calculate mass of magnesium. Mass of magnesium, we have to react with 250 cm cube of 0.5 capital letter NaHCl. The reason I brought this question is to tell you that sometimes concentration can be written as moles per dm cube or capital letter M, which means molar. You understand? So mole per dm cube or molar or capital letter M, they're literally the same. So you already know what to do with this, values from 250 down to here, convert to N, use your formula concentration times volume over 1000, because volume is a cm cube, and then get the number of moles of this and relate them together and get your answer, the mass of magnesium. All these things are very simple, guys. Practice makes perfect. So if you find my video lesson helpful, make sure you click on the subscribe button to my channel and also share my lessons to your friends. Okay, guys, let's get into the next practice question, and it says what volume of CO2 we are interested with this at STP, measured at STP. So we are looking for volume of this at STP. Remember, you are still to use that your formula that existed at STP when 1 kg. Remember, don't ever do this. Make sure you convert your 1 kg to 1,000 grams, because 1 kg is equal to 1,000. We said this already. So basically, note this, and then you are interested with this of this. So bring them down. 2 moles give us 1 moles. All right. So what you do, convert 1,000 grams to moles. Simple now, because it must exist in moles. So that mole you've got it now because of X mole of this. You understand what's happening? So let me just give you the atomic masses. Potassium is 39, hydrogen is 1, carbon is 12, oxygen is 16. I'm not going to solve it. Make sure you solve the question and provide the answer in the comment section. All these questions are very, very simple. So let's get into more practice example. Okay, guys, let's get into the next practice question. For this question, I'm going to solve it. I'll guide you through. All right. So the question says, calculate the number of moles of hydrogen ion formed by dissociating 20 grams of H2SO4. Listen carefully. Now, how does this question? This H2SO4, dissociate means you are breaking something down and it's forming ions. So basically, whenever H2SO4 undergoes dissociation, these are the ions formed. Definitely, we'll get H plus hydrogen ion plus another ion, which is SO4 2 minus. The reaction is not yet balanced because hydrogen here was 2. So basically, I should put 2 here to balance the reaction, and SO4 is correct. I'm not interested with the charges. So, but dissociation means that when you break them, you form ion. But I'm not interested with the charges. But I'm just saying that, okay, this is the hydrogen ion form, but specifically it's 2 moles of it. You understand? And this other one, and this one does not need balancing. It's already balanced. Sulfur is 1. Sulfur is 1. Oxygen is 4, oxygen is 4. So basically, we are looking for number of moles of this. We're interested with this 20 grams of this given. Bring them down. Bring them down. So H2SO4 will now give me 2H plus. You understand? So what do you do to these 20 grams? You convert it to moles. I'm not going to say much. You complete this question. Solve this question and complete it in the comment section. It's very simple. Convert this to moles. Bring it here, because now we already have 1 moles to give me what? 2 moles of this. So we're looking for X mole of this. So get the moles of this that should be here based on you converting 20 grams of H2SO4 to moles. So basically, what are the elements here? H, S, and O. So hydrogen is 1, sulfur 32, oxygen 16. You understand? They're all very easy. They are not difficult at all. So let's get into the next practice question. Okay, guys, let's get into the last practice question. Now, you can see we've solved so many questions, and I have ensured that you've practiced, all right? And at the end of watching this lesson, make sure you practice and practice more examples. So if you find this video lesson helpful, make sure you click on the subscribe button to my channel. Make sure you share these lessons to your friends to help you guys, because you can see the way we've actually, tackled this aspect so easily. Now, here's this question. It says, calculate the mass of hydrogen gas, all right? We are looking for the mass of this. We'll take note of it. You understand? Liberated were 6 grams of magnesium reborn. 6 grams of this reacted with 109.5 grams of HCl. So basically, if you observe, you can see here that normally in stoichiometry, I told you that we relate 2 things: what we are asked to get and what we are given. You understand? So in this case, you can see here that they gave us 2 different things, and they are asking us to get 1 stuff for hydrogen gas. Please take note. Whenever we come across questions like this, is on an higher aspect under stoichiometry, and that aspect is on what we call limiting and excess reagents or reactants. I beg you, take note. Whenever you are solving questions and they give you parameters for two of your reactants, remember before, they will just give us one parameter and the other one they will not give us anything, and then they will just tell us to look for something. But in this case, they will give you for both of them. So what they're expecting you to do is to try to determine which one you are to use to react with your product. You understand? To get whatever they are asking to get in the question, you try to examine both of them and look for the one that you use to react with your product. Listen, you examine both of them and determine the one, because you can't just guess. You can't just say, okay, I'll just use 6 grams of magnesium to react with hydrogen gas, what we are asking us to get. You know, they say calculate mass of hydrogen gas. Oh, I will just guess. Let me use this and do this, or let me do this and do that. You understand? Because you can decide to use both of them. You can decide to use magnesium and react and get an answer for hydrogen gas. You use same and do for same reactive with related to hydrogen gas and get an answer. That two answers can be in an option. That is why you must learn how it works. So I'm now telling you now that whenever you see a question that has parameter for both reactants, the two reactants, you know that, oh, that question is on an important concept in chemistry called limiting an excess reactant or reagent, and it's best and it's important for you to know how it works. It's another aspect of stoichiometry, and it's very easy. But in this lesson, I will solve this question. So for you to be able to solve this question, go watch this my video lesson on limiting an excess reagent. Watch the full video and come back to this last question and devour the question and provide the answer to this question in the comment section. It is extremely very easy.